I am Akhil Chandil and our project is about determining the survival rate of passengers of dynamic data set using different machine learning techniques and feature engineering techniques. The data set is provided by the Kaggle, which has the information of 891 individuals, which contain the different features like age, sex, cabin and class, etc. And we attempt to predict the survival of about 418 individuals. The objective is first to explore the hidden and unknown information on available data set to determine the correlation between the factors such as age, passenger class, fare, etc. to the chance of survival of the passengers, and then applying different machine learning models and predict the survival rate of passengers. We tackle different data cleaning techniques and try to correlate between the features provided which impacts on the survival. After all the pre-processing of the data set, we attempt to apply different machine learning models. Some of them are dense net model, logistic regression, sport vector machine, random forest and expertise to predict what sort of people were likely to survive. The pre-processing of data and some of the machine learning models are described by my teammates.
As my friend introduced about the Titanic problem, we are applying data pre-processing. In data pre-processing, we have filled all the missing data which are given to us by applying various methods. And we have removed the unnecessary columns and added some columns too. Missing data, we filled it with the median in the embarked and class field, and we dropped a column which is giving lots of nan values which are null values. In age which are missing, we applied two methods. First, the method is that we divided into groups, into 4 groups. In the 4 groups, we have divided the age group by removing the title Mr., Mrs., Master and miscellaneous. In that we can determine the age group, and then we applied, in the second method, we applied KNN on the features like family size, title, siblings, and rest of the features. In this we applied KNN and removed the remaining age, and then we have cleaned the data and came into several tables. In DenseNet we got 17 columns, rest in SVM and random forest we got 10 columns, and then rest we got 12.
It was earlier said by Atul that we are using many deep learning models for solving our Titanic model. So here I am explaining about the DenseNet model. DenseNet model is a convolutional network which connects each layer to every other layer in a feed-forward fashion. For each layer, the feature map of all the preceding layers are used as the input, and its own feature map are used as the input for all the subsequent layers. So DenseNet have several compelling advantages also. They elevate the vanishing gradient problem, strengthen the feature propagation, encourage feature reuse, and substantially reduce the number of parameters. So for our model, we have used 2 hidden layers. The reason is that by using more hidden layers, it will create overfitting. So to avoid overfitting, we have used only 2 hidden layers in our model. We also have tried using the dropout for each hidden layers, but it doesn't show any significant changes in our result. So we created using the dropout. Then we used feature engineering to create a table of shape 891 by 17, and we converted all the data into numerical data. For each hidden layer, we used a different activation function. For the first hidden layer, we have used the ReLU activation function, and for the second hidden layer, we have used both the softmax and sigmoid activation function. But the softmax activation function have given us a more accurate result. Then we have used the binary cross entropy as the loss function, and we found it that the loss function was reducing well in 40 epochs. Then we submitted this into Kaggle and got an accuracy level of up to 8 to 85%, and by changing different hyperparameters, and which was the maximum range of result.
We have tried different models in the project. I am going to explain about the random forest model, which gives the maximum accuracy, which is about 80 to 90%. random forest model is one of the most popular, powerful and supervised model in machine learning, which is capable for processing both regression and classification tasks. It is more helpful to predict non-linear data. As the name suggests, the algorithm creates the forest with number of decision trees. In general, the more trees in the forest, the most robust is the prediction. In the same way, the random forest classification, the higher number of trees in the forest gives the higher accuracy. The accuracy of the result can be improved by increasing the number of trees in the forest. For instance, it will take random sample of 100 observation and 5 are randomly chosen to build the model. The same process is repeated a number of times. Then the final prediction is made according to the observation. The final prediction is mean of all the products. The advantages of this random forest model are: first one, which handle the missing values and maintain accuracy of the missing data. Second one, it won't overfit the model. Third one, it will handle large data with higher dimensions.
As a conclusion, this project presents a comparative study on different machine learning models to analyze the Titanic dataset and to learn what features affect the result of prediction. We compared and analyzed different machine learning models on the basis of their accuracy and Kaggle score, and we got the highest Kaggle score by using random forest and extra trees as compared to all other applied models.